NASA says that Voyager 1 has become the first man-made object to reach interstellar space.
Just 8 minutes ago, Voyager sent a chilling transmission from deep space, one that left scientists in shock. Something was wrong, something no one had anticipated. Now, the world holds its breath. For nearly half a century, Voyager has ventured beyond our solar system, uncovering discoveries that reshaped our understanding of the cosmos. The next transmission could change everything, a signal from the unknown. In the early 2010s, an unusual phenomenon was detected. A space probe called IX observed an unexpected dimming of energy particles on the side facing the sun. That was strange enough, but when scientists revisited the data, they found inconsistencies. The heliopause, the invisible boundary where the sun's influence ends, was behaving unpredictably. Models predicted one thing, but space had other plans. The edge of our solar system wasn't just shifting, it was breathing. Then came an even bigger shock. Voyager started detecting unexpected changes in the heliopause, changes that defied all logic. Both Voyager probes had crossed into interstellar space, one in 2012, the other in 2018, but their data didn't match. Scientists were left puzzled. Was the boundary shifting? And, if so, what was causing it? There were no definitive answers, only more questions with every theory proposed. To solve the mystery, NASA planned to launch a cutting-edge probe in 2025, equipped to map space with unprecedented accuracy. But Voyager wasn't finished delivering surprises. Just when patterns seemed to emerge, a new anomaly surfaced, something no one had foreseen, something that raised the stakes for deep space exploration. It was no longer just about charting the cosmos. It was about questioning whether humanity truly understood what lay beyond the sun's protective reach. In May 2023, Voyager 1 encountered an unexpected issue when its Attitude Articulation and Control System, AACS, which ensures stable operations, began to malfunction. Instead of sending its usual status updates, it transmitted unintelligible data, as if it had suddenly lost the ability to communicate. Oddly enough, despite the garbled messages, everything else seemed to be functioning normally. The signal remained strong. Voyager 1 stayed properly oriented toward Earth, and its scientific instruments continued operating as expected. It was as if a robot had started speaking nonsense while still performing its tasks flawlessly. NASA treated the situation with urgency, calling an emergency meeting to determine what had gone wrong. The problem was baffling. Why had the ACS suddenly begun using a computer that had been inactive for over 3 years? Even more puzzling, the fail-safe system designed to trigger safe mode did not engage. It was as if Voyager 1 had chosen to disregard its own protocols. The situation was unprecedented. For decades, Voyager had faithfully transmitted signals, with its slow aging and occasional minor issues falling within expectations. But this was entirely different. Nearly 50 years into its deep space journey, the spacecraft suddenly acted as if it had received instructions from an unknown source. There was no apparent cause, no identifiable trigger, and no way to predict if it would happen again. Fortunately, NASA engineers identified the issue. They sent a command instructing Voyager to switch back to the correct computer, and just like that, the gibberish ceased. Crisis averted, for now. But the bigger question remained. What had caused this in the first place? The leading theory? Voyager may first have received a faulty command from another onboard computer. While NASA assured that it wasn't a major threat, an unexplained anomaly in a 46-year-old spacecraft is not something to take lightly. Scientists understood that this couldn't simply be dismissed as a minor glitch. Deep space is full of unknowns, and every unexpected event could point to a much greater mystery waiting to be uncovered. Voyager has traveled far beyond the sun's magnetic shield, drifting through the vast unknown while being relentlessly hit by high-energy cosmic rays. Perhaps one of these rays disrupted its system. Maybe its aging electronics are finally failing. Or, just maybe, something out there doesn't want Voyager to reveal what it has discovered. Susan Dodd, who leads the Voyager mission, acknowledged that the spacecraft has already exceeded all expectations. It has defied the odds, journeyed farther than anything before it, and continued functioning despite all logic suggesting otherwise. But what caused the AACS to switch systems in the first place? Scientists suspect Voyager may first have received an improper command from another onboard computer. NASA insists it isn't a serious threat, at least not yet. Navigating the route is essential to mitigating future uncertainties. This event offers a glimpse into the challenges faced by Voyagers on their interstellar journey. Now beyond the protective shield of the sun's magnetic field, the spacecraft is increasingly exposed to a harsh radiation environment. High-energy particles, such as cosmic rays, known for disrupting computer chips on Earth, could introduce cumulative errors that may affect Voyager's onboard systems over time. Susan Dodd, project manager for both Voyager missions, emphasized that the spacecraft's current challenges align with its ongoing phase of exploration. These aging probes have long exceeded their expected lifespan, achieving far more than ever anticipated while venturing into uncharted space. The heliopause marks the boundary where the sun's influence gives way to the vast emptiness of interstellar space. Initially thought to be a smooth static barrier, data from the Voyager probes and NASA's Interstellar Boundary Explorer spacecraft reveal a far more complex reality. Rather than a calm, well-defined boundary, the heliopause is dynamic, shifting, reshaping, and forming unexpected angles. Since its discovery, this enigmatic frontier has captivated scientists, behaving like an elusive celestial chameleon that continually challenges expectations. It defies a singular definition, its form and characteristics shifting with the seasons and even the drifting clouds. This ever-changing and independent nature challenges our perception of the natural world. Only two bold explorers, the Voyager spacecraft, have granted humanity a direct glimpse of this cosmic boundary across space and time. Yet, as Princeton University space physicist Eric Zernstein aptly states, IEX plays a crucial role in broadening our perspective, offering insights through its observations of energetic neutral atoms, byproducts of interactions between solar winds and the interstellar medium. By piecing together these findings, scientists strive to develop models that depict the dynamic contours of the heliopause. They envision an ongoing cosmic struggle, where the solar wind and the interstellar medium engage in a perpetual push and pull, shaping this celestial boundary in an eternal dance of forces. The Voyager mission was more than mere observation. It was a journey into the very heart of our solar system. As the probes ventured outward, they recorded the solar wind and the delicate, thread-like electric currents stretching across space, wrapping around planets like an immense cosmic gyroscope. These invisible lines defined the sun's domain, marking the edges of the heliosphere, the protective shield that separates us from the vast interstellar expanse. Yet, as Voyager approached this cosmic boundary, it detected an eerie whisper, a faint hum of interstellar plasma, hinting at the mysteries lying beyond. When Voyager 1 finally crossed into interstellar space in 2013, the world watched in awe. This was the ultimate frontier, where the sun's influence fades, its particles and magnetic fields dissolving into the unknown. For an astronaut, this marks the end of familiar space. Beyond it lies only the infinite, uncharted cosmos. 5 years later, Voyager 2 followed the same trajectory, venturing into the vast interstellar expanse. Now 17.7 billion kilometers from the sun, imagine an immense, bubble-like region shaped by the sun's unceasing breath, the solar wind, a continuous flow of charged particles streaming outward indefinitely. This cosmic shield, known as the heliosphere, acts as a protective barrier, deflecting the chilling gusts of interstellar space. But where does this shield end? And where does the true emptiness of deep space begin? This is where the Voyagers play a pivotal role. Though their journey remains unseen to the naked eye, both probes have crossed the heliopause, the invisible boundary where the sun's influence fades and interstellar space begins. Beyond this frontier, the solar wind diminishes, and the gravitational forces of distant stars take hold. Their findings offer a stunning glimpse into interstellar space, a stark contrast to the relative safety of the heliosphere. Here, cosmic rays, high-energy particles from beyond our solar system, strike the Voyagers with nearly 3 times the intensity experienced within the sun's protective bubble.